teachers typically ask a few hundred questions to their students every day. These serve a variety of purposes: to check for understanding, to refocus a chatty student, or to facilitate class discussion. Research suggests that most questions asked in a typical classroom are surface level, requiring students to recall facts or processes without engaging in critical thinking. Another pattern seen in education research is that questions are asked with the intention of obtaining a correct answer. Only 5 to 10% of the time are incorrect answers used to further student learning. While there is always a place for asking questions to build surface level knowledge and check for understanding, a vital tool in a teacher's questioning toolkit is an ability to ask higher order questions that promote student learning moving from surface to deep. This article will explore ways to think about and generate higher order questions with the use of the solo taxonomy. But first, what is surface and deep learning? Surface learning is the foundational stage of acquiring knowledge and is when students are exposed to facts, concepts, skills, and knowledge they were previously not familiar with. Deep learning occurs when students are able to consolidate and build upon the surface level learning they've previously done, although it's true that surface and deep learning can occur at the same time. Deep learning might involve integrating or comparing pieces of knowledge, or expanding on previously acquired knowledge to move it into new contexts. The solo taxonomy was developed by Biggs and Collis as a way to categorise student learning outcomes. You might be more familiar with Bloom's taxonomy. Solo is similar, but has some advantages. In a nutshell, and in John Biggs' own words, solo enables us to assess the quality of student knowledge, not of how many bits of this and of that they've got right. The solo taxonomy consists of 4 levels of complexity. The first 2 are considered surface, while the third and fourth are considered deep. They are the unistructural level, in which the student can work with one aspect of new knowledge, such as being able to identify or name a concept or skill. The multistructural level, in which the student can work with several independent aspects of knowledge. This might involve being able to describe or list a number of different concepts or skills, but does not involve being able to work with them as a combined whole. The relational level, in which the student is able to bring together several independent aspects of knowledge into an organised structure. This might involve comparing, analysing, relating, or justifying. This is where higher order questioning typically begins. And the extended abstract level, in which knowledge is brought together and synthesised to create or extend on what is known. This might involve hypothesising, theorising, or reflecting. Questions can be formulated at each level of the solo taxonomy to ask progressively deeper or higher order questions. For example, consider the following 4 questions about the solar system. Which planet is furthest from the Sun? Here, students are asked to deal with one piece of knowledge independent of other pieces of knowledge, in line with the unistructural stage of the taxonomy. Is Venus or Mars warmer? This question requires students to use 2 independent pieces of information, which is in line with the multistructural level of the taxonomy. How does the movement of the Earth relative to the Sun define day and night? This question requires students to make a connection between a planet's movement and Sun position to the experience of a night and day on the planet, and is in line with the relational level of the taxonomy. How does the Earth's position relative to the Sun affect the Earth's climate and seasons? This question requires students to use the information available to them to hypothesise about a concept they may not have learned about, and is in line with the extended abstract level of the taxonomy. Used at the right time, deeper questions, such as those at the relational and extended abstract levels of the solo taxonomy, may promote deeper student learning and engagement in the classroom. The solo taxonomy also provides an appropriate scaffold for the generation of test and exam items.